What if an AI could be its own harshest critic? I mean, not just spit out a first draft, but actually go back, review it, and make it better. Today, in this explainer, we're diving into a paper that explores exactly that, teaching an AI the very human art of self-improvement.
So let's just get right to the core question here. Can a large language model learn to be its own editor? To actually catch its own mistakes and improve its own work, all without a human stepping in. And to really get why that question is such a big deal, just think about how we work. Our creative process almost always has that vital middle step, revision. But for AI, it's historically been a one-shot deal. You give it a prompt, it generates a response, and that's it. End of story. This paper is all about tackling that huge missing piece. And this brings us right to what the researchers call the first draft problem.
This quote from the paper just says it all, doesn't it? Even the most powerful models we have, think GPT-4, they're not perfect. They make mistakes, they take shortcuts, they produce a first draft. And when we start talking about the future of autonomous AI agents, that first draft is nowhere near good enough. If you've got an agent trying to perform a complex, multi-step task like debugging a codebase, mostly right is still wrong. We absolutely need reliability. So how do we fix this? Well, the researchers came up with a really brilliant shift in thinking. What if you could turn the AI into its own critic? The solution isn't some brand new, complex training architecture. Instead, it's inspired by a skill that you and I use every single day: iterative self-refinement. Think about it. You draft an important email, you read it over, you spot a phrase that sounds a bit off, and you fix it. This paper basically asks, can we get an AI to do that too? And this brings us to their core idea, which they call self-refine. It's an approach where a single LLM plays all three roles. It's the generator, it's the critic, and it's the refiner. Now here's the kicker. This requires no extra training data, no reinforcement learning. It's all done in the moment with some very clever prompting. Okay, so that sounds great in theory, but how does this whole refinement loop actually work? It's beautifully simple, really. It's a four-step process. First, the model generates an initial output. Second, the very same model provides feedback on what it just wrote. Third, it refines that output based on its own critique. And finally, it iterates on this loop until the task is complete or it stops getting better. Generate, critique, refine, repeat. This visual shows it perfectly. It's a closed loop. The AI is essentially having a conversation with itself to improve its work, all without a human in the middle or some other model checking its homework. For creating more autonomous systems, this is a really foundational capability.
Okay, so the idea is elegant. It makes a ton of sense, but does it actually work? Let's look at the results.
This is a fantastic, concrete example. On the left, you see the model's first try at a coding problem. It works, but it's a brute force loop. It's inefficient. Then, on the right, after a self-refine loop, you get this beautiful, optimized mathematical formula. So how did it make that leap? It got there because of this. This is the actual feedback the model generated for itself. It correctly diagnosed the problem, this code is slow, and prescribed the perfect solution. It literally acted like a senior developer doing a code review on its own code. It's incredible.
And this wasn't just a one-off. They tested this across 7 different kinds of tasks, from coding and math to generating dialogue, and Self-Refine delivered an average performance boost of around 20%. That is a massive improvement to get without any new training. This chart really puts that into perspective. Let's just focus on that code optimization task. The base GPT-4 model got it right about 27% of the time. But just by adding this self-refine loop, that success rate jumped all the way to 36%. That is a significant leap in capability from the exact same model.
So what does a 20% improvement really mean in the real world? Well, the implications go way beyond just making a single chatbot response a little bit better.
We're not just talking about editing text here. For developers who are building the next generation of AI, this is a foundational step toward true agent autonomy. An agent that can evaluate and correct its own plans is just fundamentally more capable and reliable. So for any developers watching, what does this actually unlock for you? It means agents that can generate a plan and then self-correct it when it's flawed. It means agents that can write code, run it, see an error, and then autonomously debug that code.
Ultimately, it means building more robust, reliable systems that need a lot less human handholding.
Now, the authors are very clear about one key limitation. This technique really relies on having a powerful base model to start with. They found that less capable models, well, they struggled to give themselves useful feedback or even follow their own instructions. So the quality of the critic really depends on the smarts of the underlying AI. Which leaves us with a pretty mind-bending final question. If an AI can master the human skill of critiquing and improving its own work, what's the next human-like skill it's going to learn?
This is for entertainment purposes only.